And I intended to put this on the other video, but somehow managed to hit stop and didn't get it there. That's why this video is in two parts. Even though these look kind of like histograms, it really said to imagine each box as a dot. So this was a person's way on the computer of kind of making a dot plot of this data. So that means if I'm looking at these two data sets, there's 1, 3 in this data set, and if I were going to list this data out, which I'm not, it would be a 3, 4, 5, 6, 6, 6, 7, 7, 7, 7, 7, 7, etc. So what I did first, it wants me to find the mean and median and whether it's greater for data set 1, equal for both, or greater for 2. So I went ahead and actually just calculated each of those. Instead of just eyeballing. I can do some eyeballing here and figure out that it looks like data set 1 is going to be certainly greater for the median and the mean, but it doesn't hurt to actually find those values to verify that. The more data you have and the more that you base your answer on actual numbers and values, the better you are. The next thing I did to find my mean, I just found the sum of each of these columns. So there's 1, 3, 1, 4, 1, 5. There are 3 6s, so the sum of this one is 18. The sum of this one is 42, and then 64, and 27, 20, 11, 36, and 52. So then I went ahead and I said, well, I counted up, first of all, how many squares there were here, and it turned out that there were 55. Oops, sorry about that, there were 33. I can't read my own handwriting. And when I added all of these values together, I found a sum of 282. So my mean, I took 282 divided by 33 to find that this mean was about 8.5. The median is the middle value. If there are 33 squares here, then think about it. There would have to be 16 on one side of the median, 16 on the other. That would take care of 32. The 33rd value is right in the middle. So all I need to do is to count to the 17th square. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. This square would represent the median. So that square is in the value of 8, so the median is 8. The second set of data, I did something very similar. I said, again, the sum 1, 6, 12, 24, 25, 6, and then these are all singletons, so 7, 8, 9, 10, 11, 12, 13, 14, and then 30 because there are two 15s. When I added those together, I found a sum of 188. There weren't as many squares this time, there were only 31. So I ended up taking 188 divided by 31 to find that the mean here was about 6.1. And I could sort of eyeball this and see that it should be lower because a big chunk of the data is over here to the left in these smaller values, whereas I not only have some larger values here in general, but the biggest chunk of data is right here. My median, if I have 31 squares, there would have to be 15 on one side of the median, 15 on the other. That would take care of 30 squares. So the median is going to be a value in the middle. It's going to be the 16th square. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And it doesn't matter which end of this I come from. I usually, from the left, I start at the bottom. So 15. Oops. 15. Let me undo that. It should be the 16th square. 16th square. So that's going to represent my median in this case, which means my median is 5. So this mean is greater than this mean, greater for data set 1. This median is also greater than this median, greater for data set 1. And just to practice how to do a 5-number summary from this, I wanted you to take one of them and do that. So the first data set, my minimum is 3. I already calculated my median as 8, and I can see my maximum value is 13. I just have to go find my quartiles. Well, if there are 16 squares to the left of my median, then that means I'm finding the median of these 16, so it's going to be 8 and 8 with my median falling between those two. So I need to find my 8th and 9th boxes values and then take the median of those two. 1, 2, 3, 4, 5, 6, 7, 8. My 8th and 9th boxes are both going to be in this column, so it is 7. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Let me see. 1, 2, 3, 4, 5, 6, 7, 8, and 9. My 8th and 9th boxes, one is going to be at 10, one's going to be at 11. So for my third quartile, I'm going to have to take 10 plus 11 and divide it by 2 to get 10.5. Let me double check that. 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's say these are the two that it's between. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oops, sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, that works. Sorry about that. Got a little discombobulated for a second. Now, the next thing says, I'm looking at this histogram and write a question about the employee salaries that cannot be answered. Well, I don't know if this is all employees from one company. I don't know what kind of occupation they do. Are these average salaries? If they're average salaries, are we talking mean or median? I mean, there are a lot of things I could ask that I can't answer using this histogram. So a couple of things I put down. What type of work do the employees do? Are these average salaries? If so, are they mean or median? Are these all full-time employees? I would hope that the people who earn between $0 and $10,000 are not full-time. So if this is a mixture of full-time and part-time, maybe even 3/4 time and half-time, then this isn't necessarily comparing very well if you're wanting to compare who makes more money like per hour or something. So we don't know the hourly rate of these employees. There's just a whole bunch of things that I could write here, and probably better to write, a couple things. And then write a general statement about the salaries these employees receive. I said the largest number of employees earn between 44 and 54,000. Not more than half, but the largest single category is between $44,000 and $54,000, where the smallest numbers of employees earn less than $10,000 and more than $88,000.